find how the Pythagorean theorem works and find unknown side lengths. So we're going to be looking at both those two things today. So it says the Pythagorean theorem is a geometry theorem named after an ancient Greek mathematician named Pythagoras. Pythagoras studied relationships between shapes, and like we did in our homework last night, he found some of the interesting relationships between squares and right triangles. In this video, you'll see a quick overview of the relationship of how Pythagoras and other mathematicians throughout history have found these relationships. So it's a pretty short video. And I just need to make sure I got my speaker on for you.
A more profound link with geometry came from the Pythagorean theorem. In any right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. In other words, the sum of the areas of the two small blue squares is equal to the area of the large square. Here's how the Chinese proved this theorem. Make 4 copies of the original triangle. Put this here for reference. Now slide the triangles around and keep track of the areas of the blue regions. And we see that a squared plus b squared is always equal to c squared. When all 3 sides of a right triangle are integers, they're said to form a Pythagorean triple. Here's one with 3, 4, and 5, and 5, 12, and 13. Another one with 8, 15, and 17, and there are infinitely many more. Pythagorean triples were known long before the time of Pythagoras. This Babylonian clay tablet, written around 1700 BC, contains 15 examples of Pythagorean triples, some of the numbers being quite large. No one knows why the Babylonians were interested in these triples, and as far as we can tell, they did not know the general form of the Pythagorean theorem. The Pythagorean theorem appears in Euclid's Elements in Book 1 as Proposition 47. This Arabic diagram shows Euclid's proof. It can be simplified with computer animation. Drop a perpendicular from the right angle to the hypotenuse and extend it to divide the large square into 2 rectangles. Euclid's idea was to show that this square and this rectangle have equal areas, and this square and this rectangle have equal areas. Animation shows why. All parallelograms with the same base and altitude have equal areas. So all these parallelograms have equal areas, as do all these. And that's all there is to it. So we see that the square of the hypotenuse is equal to the sum of the squares of the legs. Still not absolutely convinced? Make a copy of the small square in the middle of the large square. Make cuts along the sides and out to the edges, and rearrange the pieces. All the pieces from the big square fit exactly inside the other 2 squares.
Taken across the bottom of the goalpost from one end to the other. It says we run the length, which is 120 yards from goalpost to the other. Stretch it tight, and then at the bottom of the goalpost so that it lies flat on the ground. So suppose you add 1 foot. So first off, let's make sure. If this is 120 yards going across, how many feet are we talking about? Because we're talking about adding 1 foot, because this is 120 yards, right? Which means how many feet? Okay, 360 feet. So we're just thinking this is 360 feet. And we are going to add 1 foot right here, right? And the question is, that I want you to just circle your answer right now. How high should I be able to lift that off the ground? High enough to only put my finger under? High enough to crawl under? High enough to walk under? High enough to drive a truck under? So vocabulary, if you would read, please, Jacob.
Right triangle and a triangle with 1 right, 90 degrees.
Keep going.
The right triangle with 5 subpoints and the right angle are called legs.
Frickin' keep going.
In a right triangle, the side that is opposite of the right angle is called the hypotenuse. The hypotenuse is always the longest side of the right triangle.
Let's keep going.
The Pythagorean theorem is a pattern that is always true for right triangles. It relates to the lengths of 3 sides to the areas of the squares of 3 sides.
So it must always only works for right triangles, and here is algebraically, so in that video they showed us why it worked. It says if we have signs in algebra, this is called our Pythagorean theorem. It says that a squared, so the sum, right, that's what this is our sum, of the square of the legs, square of a square, right, square of the leg, and the square of the other leg is always equal to the square of the length of the hypotenuse. So 3 squared plus 4 squared is equal to 5 squared, because we know that 9 plus 16 equals 25. So those were the areas, right? So that's why today, in that project before, like in those questions, this area, so the side equals 3, and this area was the 9. The area was the 16 and 25, and that only works for right triangles. So it says we want to find the length of the hypotenuse of a right triangle with 5-inch legs and 20-inch legs. First thing I'm going to have you do in your assignments each time is write down the formula. So first step, write a squared plus b squared equals c squared. Now we're going to fill in the numbers. Well, they told us that these were the legs. The legs are always the two smaller, and the hypotenuse is what we're solving for. So we are going to put, and if you don't have a calculator, you might want to grab one. Some of you might have memorized these perfect squares for 15 and 20, but if you didn't, please make sure you grab a calculator. So if we are grabbing and we were taking 15 squared is 225, plus 20 squared is 400, right, equals c squared. We're going to add those two together. 625 is equal to c squared. Now, at this point, c squared equals 625. So in order to get rid of the square root, what did we just learn gives us, if we want to get c squared, we only want c, we are going to take the square root of c squared, which means that gives us c. I have to take the square root of 625. And the square root of 625 is, if you put it in your calculator, 25. So when I answer the question, it says find the length of the hypotenuse, and you put c equals 25, and you get a half point off or a point off because you didn't label your answer. And the answer is that it is 25 inches. Okay. On the top of the next page, it says now you have a right triangle, this time, as we are looking at it. And it says this time we have a hypotenuse between 15 on the leg 5. So sometimes it is helpful for you to draw the triangle, but you don't have to. When you're drawing that right triangle, you do want to put in your A, your B, and your C. And so in this case, if we start with a squared plus b squared equals c squared, they told us the hypotenuse is 15. That is my C. 15 squared equals, they say a leg is 5. Does it matter which leg we call 5, A or B? It doesn't matter. So if you want to go with a squared plus 5 squared, you could. Here's the most common mistake that I'll have people tell me. They'll tell me that a squared is now equal to 10 squared, which is a bad mistake. A squared is not equal to 10 squared. You cannot take 5 squared and subtract it from 15 squared and say 15 minus 5 is 10. You can't do that. Because a squared plus 5 squared is 25. And 15 squared is, we just did this one, 225. And so now you are going to subtract 25. So if you don't have this worked down in your paper for your notes, please write it down. You're going to subtract 25 on both sides. When you subtract 25, we get a squared equals 200. Now, if I ask you for an exact answer, you do not want to use your calculator for this, right? You want to do the factoring that we just did. You're going to tell me the exact length of this, which if you are an architect or building or doing something like that, or you're building with materials, you want exact, right? So we are going to say this is the square root of 200. How do you simplify the square root of 200? 100 times 2. This would be 10 square root 2. Do you agree? Square root of 100. But more than likely, if we are talking about a length in inches, and you talk to any person and they go, oh yeah, the length of that is 10, square root 2 centimeters, they're going to go, what? So we are going to put this in your calculator or square root 200 in your calculator. So please do that now. Square root of 200, or put in 10 square root 2 in your calculator. And our final answer that we want to write down is that the length is 14.1 centimeters. So, if I do not specify, you can always leave your answer exact, and this is our approximate, okay? Most of them, they're going to ask you to round it to the 10th place, is what the directions will tell you. So if you please take a look at those next ones down in your notes. I'm going to have some of you coming up to the board to show us your work. I do want, as you come up, to do a squared plus b squared equals c squared. So we're going to put these up in a few minutes. Check with your shoulder partner as so those were your answers again. Keeping, if you're looking, this is our exact solution, right? And this is our approximate, okay? This one is the exact solution, and then labeling them always with whatever unit you are talking about. So keeping the meters, keeping the inches, keeping your labels with it. So let's go back to the problem from the beginning, right? At the beginning, we said that this was our 360, right? So if we are looking at this, this is our 360 going across. And which means if I'm looking at the Pythagorean theorem part of it, I'm looking at how long is this side? 180. We added 1 foot, which now makes, if I was adding this whole thing, right, it would have been 361. So this going up, I had to add half a foot up to this point, right? So I have 180.5. So let's check and see what we could do. A squared plus b squared equals c squared. A squared we're going to leave. B squared is going to be 180 squared equals 180.5 squared. Putting that in your calculator, we get a squared plus 3,200, 32,400. Put in 180.5 and square it on your calculator. Comes out to be so now we have to subtract these two, right? We're going to subtract 3,200, 32,400, both sides. Do you agree with your original prediction? A squared, right, is equal to 180.25. Square root of that. 13, approximately, 13.43 feet. 13.43 feet. So if you think of like a 6 foot tall person, right, 12, 13, the truck could drive under it, right? I know it. Doesn't that surprise you? Because most of you had B for your choice. Yeah.
If we don't put those wiggly equal signs, we need them.
Well, it's not exact, so I'm probably going to look that when you approximate it, that you tell me it's not equal, that we go with this one. Yeah. Good question, Sanjay. Okay. Last question. So you're going to have some application problems. I think sometimes they're not too harder ones, but again, this one, if any of you have ever gone parasailing, right, going sailing behind the boat. So in this case, they tell us that 200 feet behind the boat, and that rope is 300 feet, and the question is how high up the water are you? Okay? So if we are looking at it again, we are simply going to start with our a squared plus b squared equals c squared. What do we know? We know a squared and c. We know a and c, right? We know 200 squared. Does it matter if you put it in place of a or in place of b? No. What's nice about squaring 200 is if you square 2, you get 4, so this should be 40,000. You're just doubling the zeros, right? Plus b squared is equal to 300 squared. So 3 squared is 9, and again, double the zeros, so we need to have 4 zeros, so 90,000. Someone said, do I have to show subtracting 40,000? Could I write down b squared is equal to 50,000? Some of you just make some really silly mistakes, but sure, you could do it like that. What are we looking at for our length? B is going to be equal to the square root of 50,000. Not a perfect square. So we are going to say it is approximately, how many feet off the water are you? 23.6. Anyone here ever parasailing? I have never. It's scary. Do you feel like you're up that high? Anyway, all right, so as you are looking, okay? So tonight's assignment, you are doing on page 616, you are doing question 1, 2, and then question 5, they're asking you for the error, and then 6 to 22. So those last couple questions are asking you to take a look at those, try and figure out which one you are doing,